So I think last class we have started. What is the critical difference? So when do we use critical difference concepts? When you talk about rejecting the null hypothesis, rejecting the null hypothesis, then we always interested to know that which treatment is significant, or either I can say that which pair of treatment is significant. So, for example, if I'm rejecting, if you're saying rejecting H naught, that means you are accepting H1, right? So, accepting H1, that means that you are saying the mu A is not equal to mu B is not equal to mu C is not equal to D. But further, I'm interested that out of these four treatments, which treatments are equal. Okay, so it's called critical difference. So one can able to check using the critical difference concept. So to test this, either you can write notations, that is will be called T. It's just notation. Okay, we write na Ti equal to Tj. This one. So similarly, we have a TL is equal to that is your tau L is equal to tau m versus tau L is not equal to time. So now I'm comparing the only two treatments. Only two treatment matlab it is basically your T test or Z test, okay, which we have maybe going to see in your paper one. Okay. So how do you compare that two test and one test? That is all we're going to study in your paper one. Okay. So just try to understand. Even we have I have explained in my previous semester some of the concepts of T test and Z test. Okay. So how to do that? The procedure is same. Ti dot need to obtain what is Ti dot? It's a total of observation where ith treatment is applied. That is your summation over J because you're putting dot on J. Na? So J is running from 1 to Ri, Yij. What is your Ri? Total number of applications of ith treatment. That is Y bar I dot. Okay. Okay. So how to get this Y bar I dot? It's what actually is your Ti dot upon Ri dot. Ti dot, which is the total number of observation where ith treatment is applied, it divided by I can say Ri, which will give us the Y bar I dot. Hence, we can find Y bar L dot and Y bar M dot. So this is basically we have data with us, and then we are finding their I can say, for example, you have a treatment A and you have given this data. Okay, treatment B, we have given this data. So based on this, you can find Y bar 1 dot. Based on this, you can find Y bar 2 dot, like that. Okay, and you want to compare whether this particular Y bar L is equal to Y bar M or not. Okay, so what you have to do, calculate the critical difference. So here, if you just look at here, we have used the T test. Okay, because ANOVA and everything is used when we have a small sample. Okay, so if there are two samples and the sample size is less, then one can able to apply the T test. Okay, so it's a T degree of freedom comma alpha by 2. It is into, okay, it is into square root of, this is your basically your S square, which is known as mean sum of square error, mean sum of square error into 1 upon RL plus 1 upon RM. Means it is the observation under the first category. That is the how many observations we have in A. plus how many observations you have in B. Okay, so that is your 1 upon RL plus 1 upon RL. And you can just look at the difference. You can you have this y bar L and y bar m dot. Take a mod of that. Okay, take a difference in mod of that and check whether this criteria satisfies or not. Decision criteria is reject H naught if mod of y bar L dot minus y bar m dot greater than critical difference. So you can reject the null hypothesis when this criteria satisfies. So this is used only when your H naught is rejected. Make sure that हमेशा नहीं use करना है. When you're going to use this method, when your H naught is rejected. Okay. So if H naught is rejected, you can always go by that method. So any question here? Anyone can put on the chat box if you have, or you can ask directly. Go to chat box and write down why. So we proceed. Can you proceed now? Go to chat box and write down why. So we'll proceed with the advantage. Fine. Fine. Let's move to the advantage part of this. So what are the advantage of this CRD? What are the advantage of this CRD? See, as I said, it's a complete randomized test and it is used basically when you are doing small experiment. It is not used for the large data. Okay, so it is useful in small experiment. For example, lab experiment where the units are homogeneous and small in number. Okay, so when you have a small, I can say small experiment, then one can use this method. Design is flexible and can have any number of repetitions. So you can do as many repetitions you want. Further, any number of treatments can be also used. Statistical analysis is very simple. As you have already seen, the analysis become very simple because you need to just obtain this, I can say, sum of squares and degree of freedom as we have done it in the case of one-way ANOVA. Okay? And you know how to do it, the one-way ANOVA problem within 5 minutes in calculator, right? That is all simple for you. Only thing is that you should know the notations, how it can be properly written. That's it. Okay. It provides maximum degree of freedom for estimation of experimental error. And certain disadvantages also there. It is not useful field experiment where the plots are not homogeneous and they're large in the number. So as I mentioned, if you have the very big large means area, or you can say your plot is not homogeneous, okay, then this method basically you cannot use CRD because it is going to be like means your error will be the more in that case even if you use it. And principle of local control is not used. So here we didn't use this principle which is given by R.A. Fisher. So this is one of the disadvantage of CRD. Since there are so many things are involved into that, okay, but just try to understand how that is one thing is useful for you. Okay. So as I said, CRD means it's very simple. If you know one way ANOVA, only if you just compare one way ANOVA and I will say uh, CRD, if you just compare their calculations and everything, it is going to be same. Okay. Only instead of RI, you have to use NI instead of K, some other notations. Okay. So just better to have just compare it and you can try to see whether you can able to do it or not. So one may also check that how you can do that all calculations. Okay, because that is also important. So shall we do the practical based on this, or we can see the next design first? Yes. Shall we go ahead with the next design? Yes or no? Go to chat box and write down if you want to go with design. Otherwise, because I thought let me finish this design, then we can go simultaneously with both the practicals because it will be then become easier. Or we can finish first problem based on that. What we do? Shall we go to the problem based on the practicals so that problem will be get over. Let's see whether I have a solution of this one. CRD. So this is your practical based on CRD. Okay, so we'll try to solve this. So as you can see, this is a third practical. Okay, 2.2.3 completely randomized design, and you have this particular feed stuff. Okay, that is ABCD, and tried on 26 is given below. Okay. And the 26 are treated alike in all respects except the feeding treatments, and each feeding treatment is given to 5 chicks, and analyze, that means these all chicks are given to the 5 treatments are given to the 5 chicks and they have observed these values. Means actually they have observed their data which is called weight. So they have just found the weight on basis of treatment A, treatment B, treatment C, and treatment D. Okay. So we need to be analyze this, and based on this, you need to be just check, analyze the observed data, analyze observed data weight gain by baby chicks feed on different feeding materials composed of tropical feed stuff. Okay. So it's something like a small baby we have, and we have given treatment like A, B, C, D, and we try to check whether their weight will be normal or more weight, or is there a loss in weight, and etc. etc. Okay, that's something like. So when you have these type of data, you can just look at it is exactly same type of data we have seen in one way ANOVA. Okay?
Yes, sir.
It is the one-way ANOVA. So we can start doing one-way ANOVA like as we have seen for in the case of one-way problem. So I will just share that how you can do that. Okay. So how to do this? Just a minute. I will paste the problem so you can start doing this. Equal number 4.2.3. So what you have to do first, you need to just write down. See, as you did, if you remember, you how to do it that problem of one ANOVA, same way you have to proceed. Okay, so just calculate first. Just calculate like how you use that treatment. Remember, same way we have to do it. Same way. There is no change in the data. So first you find out how many k are there, how many n are there, right? Find out T1, T2, T3, T4. Instead of this n, now we have r. Instead of this, now n we have a r. Even grand formula is same, CF is same. Find out treatment sum of square using the formula Ti square upon Ri. Okay. So let's find out first all total. That is your T1, T2, T3, T4 because we have four treatments. So just find out and let me know what could be your answer. N1, N2. Instead of writing N1, N2, I can write R1
R1.
because we have according to R1, R2, R3 formula, right? So one can use that way. So how many treatment we have? In the first case, R1, R2, R3, R4. So how many R we have here? I will be say K. K will be 4 because we have 4 treatment. Just give me 1 minute. Just give me 1 minute. Just find out total of this and then you can stop. Just give me one. So if you just look at there, we have used N1, N2, N3, N4. Here now we are using R1, R2, R3, R4. Okay, that much difference is there. So whenever we have a problem of like treatment and experimental problem, na, instead of N we can use R. Okay, otherwise it has same thing. Even if you use N, doesn't matter. Okay, doesn't matter. But basically when it is come to the experimental, we need to always use a journal notations. Okay, it's just matter of using notations. So what would be grand total? Anyone found grand total?
1695.
Let me know grand total.
Sir, 1695.
What could be your grand total? Yeah, correct. So 1695. And once you get grand total, you can find CF. CF will be, it is simply grand total square upon capital N. Grand total square upon capital N. Okay, so that will give us the grand total. So just finish this CF value and then find out total sum of square. Total sum of square. And you know how to find total sum of square? Double summation Yij square minus CF. So you can feed these all data in SD mode. You will get double summation Yij. And then similarly you can find out sum of square due to treatment, which is simply Ti square upon Ni minus, or I can use Ri because I have used general notations Ri minus CF. Yeah. So double summation will be 18445. Correct. So this is nothing but 181,445 minus CF. Just check whether CF you are getting this one 143,651.25.
Yes, sir.
Just subtract with this. So 14365 1.25. So this would be, is that 37793.75. Just check whether this is coming right or wrong.
Yes, yes, sir.
And this would be how do you get this one? Treatment square upon Ri square 219 divided by 5 square 31355 divided by 5 and so on. Okay. So according to that, you can make that correction. You can calculate. So this is 219 square upon 5 plus 355 square upon 5 plus 407 square upon 5 7 square upon 5 minus here. So when you just do these calculations, you may get 26234.95. Just check whether this is right or not.
Yes, sir. Sir, right.
And then write down hypothesis, which is what is the hypothesis? H naught. There is no significant difference on different feeding material composed of tropical feedstuff. So whatever the questions asked here, you can write down same thing. Okay, there is no difference in the different feeding materials composed of tropical feed stuff versus H1 is a not H. And now based on this, you need to be create a what do you call ANOVA table. Just copying this ANOVA table. So this is the ANOVA table. Okay. And now you can just write down these degrees of freedom based on your observations and conclude your results. So if you are done with this one, let me know. Yeah. So I feel this will be the total 20 observations. So n minus 1 become 19. 4 treatments, so it is going to be 3. And so 16 minus 3 become, sorry, 19 minus 3 becomes 16. And you have already calculated the sum of squares, right? So you can just substitute the sum of squares. So this would be, I feel, 3, total sum of square obtained 3, 7, 7, 9, 3.75 and treatment 26234.95, and when you do the subtraction of this would be 1155.8.8. Maybe you just do the subtraction and see. So when you just divide this quantity by 3, you will be get mean sum of square, which is 8744.9833, and this upon this will be get 722 upon 421. And when you just divide this mean sum of square due to treatment divided by error sum of square, you will be get FCAL, which is 12.1050. And you can find out, you can check that this value is going to be 3.24. Just check whether this is right one. And based on the decision criterion, what is your conclusion? Go to chat box
Sir,
and write
reject
down
H
your
naught.
conclusion.
Reject H naught.
Reject H naught since
FCAL greater
FCAL
than
will
FCAL.
be FCAL will be greater than FTAB. So we reject H naught. We reject H naught. And what we can conclude, if we reject H naught, that means I can say that there is significant difference there is significant difference. So instead of is no degree, you can just make it that it is significant difference. That's it. So there is significant difference because you are rejecting H naught. No? So this is exactly same way as you did in the one way and one. You can follow the same. Okay, you can work on that how you can able to solve the problem. So whether it is a problem of one way ANOVA or whether it is a problem of CRD, it's going to be same. Only thing is that instead of writing N, you write down R, or you can like it's a matter of notations. Okay, so make sure that your notation should be correct. That's it. Any question? Anyone? So let me.
Hello, sir.
If you have any question, you can ask.
Hello, sir.
So around 19 students attended to their practicals. Okay, so they will get only attendance for this practical.
Hello, sir.
Similarly, you can finish this question number 2. Okay, just finish your question number 2, and with that your practical will be get over. Now if you just try to use this formula, try to use this second question. In that second question, see here we found a significant difference, means that you are rejecting H naught. Okay, you are rejecting H naught, and you have, then further we are not saying that you can check the difference between any of these which treatments are equal or not. Okay, if they will mention like which treatment like between A and B, which treatment is best, then you have to go for the critical difference method. Otherwise, you no need to go for the critical difference method. Okay, so that you can make sure that there should not be any confusion. And then you can try for, similarly you can try for question 2, and then you can, like, you can use the same concepts and same formula, and you can send me your uh, complete that, and you can send me your pic of the same. So write today's date for CRD, it is complete randomized test. See, these practicals are not taking much time because we have already uh, done, the one way and two way. That's why it was not taking much of time. But other practicals will take much of time. Like once we go for LS, that is unit 3 and 4. Okay. Unit 3. Then it will take much time. So try to finish this, and then we can. Uh, right now, you can, some of the questions is there. What is the due date for submit practical? So this time I'm not asking for submit your practicals. Keep ready with you. Okay? Keep ready with you, and